Alright, so let's work on some compound inequalities. And that is those are inequalities where two or more inequality statements are joined together with words and or. So we'll work on the and types now. This is what we'll work on first. Find the value of x such that 2x is greater than 10 and 3 times x is less than 30. So there's two kind of conditions that have to be true in order for something to count as a solution to this compound inequality. So it can't just be 2 times that number can't just be greater than 10. It has to be 2 times the number has to be greater than 10, but also 3 times the number has to be less than 30. So there's a narrow range of values that'll count for this. So I'll show you how to do this. This is a little bonus. I wrote this green thing in set builder notation, just a little practice for you. If you're not into that, or if it's confusing, or if you're not interested, that's fine. Don't worry about it. You can ignore this. I just translated this word problem into set builder notation. Find the value of x such that 2x is greater than 10 and 3x is less than 30. This is saying set A is the set where x is a real number such that 2 times x is greater than 10. B is the set where x is a real number such that 3x is less than 30. Determine the union of A and B. Excuse me, the intersection of A and B, where they overlap, where they're both true. Okay, so that's just a little, this and this mean the same thing. So if this doesn't fire you up, don't worry about it. Okay, so let's find the value of x such that 2x is greater than 10 and 3x is less than 30. So you just deal with these individually first. So we've got 2x is greater than 10, and we've got 3x is less than 30. Okay, so let's just solve each one individually. So I'm going to divide by 2 to get x by itself. So we've got x is greater than 5, and here I'm going to divide by 3 to solve for x, just to get x by itself. So x is less than 30 divided by 3 is 10. So I could write the solution as simply x is greater than 5 and x is less than 10. That's fine. There's more economical ways of writing it. I could say that x is less than 10, and x is greater than 5, or 5 is less than x, and x is less than 10, or x is between 5 and 10, not inclusive. So 10 and 5 wouldn't count as a solution, but anything between 5 and 10 would count. So this would mean the same thing. That would mean the same thing. You could also graph this. I'm just showing you different ways, so this kind of takes on some meaning. Here's my number line. I've got 5 here and 10 somewhere up here. So my solution set would be, so I can't include 5 and 10 because it's greater than 5 and less than 10. So 5 and 10 wouldn't count, but anything greater than 5 and less than 10 would count. So my solution set would be this. Here's the region where all the numbers are that would count for this compound inequality, where it's both greater than 5 and less than 10. And I could I could also write this in set builder notation. The intersection of set A and B is the set where x is a real number such that what are my answers? X is greater than 5 and x is less than 10. you know, these all mean the same thing. Yeah. So the idea is that the solutions have to solve both requirements in order to be, to really count as a solution to a compound inequality. So let's do one more, or at least get started in this. We've got 2/3 of x is less than or equal to 12, and negative 1/3 of x is less than negative 9. So deal with them individually first. So I'm just going to write it like this. 2/3 of x is less than or equal to 12. And it's also true that negative 1/3 of x is less than negative 9. So I'm going to get x by itself. So I'm going to divide by 2/3, which is the same thing as multiplying by 3/2. So I'm going to multiply both sides by 3/2 over here. So I've got x is less than or equal to, so 12 times 3 is 36, divided by 2 is 18. So x is less than or equal to 18, and so I'm going to divide both sides here by negative 1/3, which is equivalent to multiplying it by negative 3 over 1. Just flip it over, times negative 3 over 1. Now, when I multiply or divide both sides of an inequality by a negative number, I need to remember to flip the sign. So I'm flipping the sign now so I don't forget. Okay, so these cancel out, so I just have x on this side. That's a 3, not a 7. So negative 9 times negative 3 is positive 27. Divided by 1 is just 27. So x is less than or equal to 18, and x is, x is greater than, 27. So just, let's see, I'll just draw this on a number line, so you can visualize what this is saying. So x is less than or equal to 18. Interesting. This doesn't have a solution. Sorry about that. Yeah. Oh, maybe I did that on purpose to show you, just in case this sort of thing happens. I don't know. This was a while ago. So I've got 18 down here, and I've got 27 up here. Okay, so if I were to graph these individually, what would happen is, so x is less than or equal to 18. So 18 would be okay, and then anything less than 18 would be okay. So that would be this part. X is greater than 27. So 27 wouldn't count, but anything that's greater than 27 would count. Okay, there's no intersection here. There's no overlap. So it's impossible to fulfill both conditions. So the solution to this individually you'd be okay. If it were just 2/3 x is less than or equal to 12, I could solve that. This would be a graph of the solution set. But because I'm saying both these things have to be true. So x has to be less than or equal to 18, and x has to be greater than 27. Well, if you visualize this, look, there's no number where both these things is true. So the solution set is the empty set, meaning there is no solution. So you can say empty set, or you can say there is no solution. Okay, there's no number where both those things are true. So there you go.